I came upon a slight issue with this display tube while working on the final design of the Bluetooth power bank amplifier speaker thing. And the issue is that if you have a fairly low anode voltage, like this is currently at 6 volts, I want to run this at 12 volts. Should be like this. But I'll just turn it down here. And I'll also knock the exposure down another little bit. It's much more visible then. You can actually see that now if you heat it with DC, and this only happens with DC, and we'll talk about why in just a second, you can see that the top filaments light up bright and evenly, while the bottom filaments, so it almost looks like an eye, but they only light up in the center. And this is caused by, if you heat this with DC, and if you have your ground lead from your anode supply connected to one side, then there is a potential difference over this heated wire, over this filament here, and this causes this. And if you turn this around, these will actually be fully lit, and these will be partially lit. And you can actually see this on this flashlight that I built. But if you can only see this with the exposure like this. If you're looking at it with your bare eye, you can notice it, but it's not as pronounced. Although with the lower anode voltage, it's quite definitely visible, and it's also it doesn't look all that great. I mean, it's almost tolerable at 12 volts. But I'd like to fix this. And so the idea is we just need to change the polarity over this filament. And I'll put this here. We need to change the polarity over this filament. With a frequency of about, I don't know, 50, 100 hertz. And what I wanted to do is, it's just my first idea, is just to use some sort of oscillator. Generating 100 hertz or whatever much. Then I should probably change the exposure again so you can actually see something. And this will feed into an inverter. And then we'll have our frequency here. I call this just F, and this is inverted F. And with this, I want to drive an H bridge like this. Well, a double H bridge really, and then double half H bridge. And then we'll have our filament in between here, and now we'll get basically forwards and backwards if this were a motor, but really just an inverted square. Will look a little like this. with ground being here. And this should actually do nicely. The chips I want to use for this are these, what are they called? L911OH. So let's call this L991OH. And this we'll just use a 7404 probably. Or I might even do something like an NE555. Or I might even do something like, instead of doing this, just use a transistor multivibrator so I can save up on 2 chips. I have to think about this, but I might do it like that. This is where I actually am now with the generating AC filament current for this VFD tube. If I knock down the exposure here, so I mean I can go down quite a lot, and now it's just beautiful with a slight bit of shadow on there, what I'd call it, but it's a lot better than it was before. And how I did this is basically just as I wanted to do before, but I simplified the circuit a little. I'll just get the exposure up again. So what I basically designed here is a 2 transistor multivibrator, and then that just feeds directly into the half bridge chip, which is getting just a little warm. Yeah, I might have to do something about that. Although it's not too bad. I mean, maybe put some larger pads on there to help it radiate a little bit of heat. But let's look at a circuit that does that, which is just 2 transistors, and these are BC547s, which are easily my favorite small signal transistor, BC547. And we've got 12 volt coming in here, like this, and also here 12 volts. It's rated to exactly 12 volts, so I might have to do something. I might even have to regulate the 12 volts, because the battery voltage can go over 12 volts in the speaker, can go up to 12.6. So an easy solution would be to just this draws maybe 100 milliamps, probably less. An easy solution would just to put 1 or 2 diodes in series with that, and that should just work fine, although it's a bit dodgy. Well, anyway, this works. And now it's staying focused. So this is just a classic transistor multivibrator circuit with 2 transistors and 2 capacitors, 4 resistors. You can read up on the theory of this, and I choose the components so that this oscillates just about 50 kilohertz. So out of the actual audio spectrum, so you can't hear the interference that it puts into the amplifier. I hope that it doesn't do anything to the amplifier, anything bad, because it can still be a problem if the amplifier actually oscillates in a region that you can't hear. But yeah, you could either design it to be below the frequency that you can hear, so maybe 20 hertz, but then you would actually see flicker on this, so I designed it to be at 50 kilohertz. It's probably also faster than this likes to do, maybe it's getting hot because of that. I'll have to look at the datasheet again. But yeah, this just produces a square here like this, and then it produces the inverse of a square here, so it would look a little like this. Yeah, you get the idea. And this basically makes this, the current in this go this direction, then this direction. It just keeps repeating over and over again. And this works very well. And it kind of wants to, I kind of want to redesign this now, so it has that fixed, because you can see it. I never really bothered me to this point, but now I kind of want to fix that, because I always wanted to do another revision of this anyway, where it's much simplified. This has it's a little bit weird in the way it's constructed. But yeah, maybe I'll do this sometime soon. But for now, this works just about fine. And I really like how it turned out.